So, hello and welcome to another episode of the Fullstack Network. Today, we're going to continue with the remote control car that is being controlled. Oops, I can hear myself. So, today, we're going to continue basically building the car with control from the chat. We already have the chat controlling the car. So actually people can already control the car. Let me just verify that the car is flipped, so you can actually go ahead and control it. Now this is kind of the window that's connected to the Pi over on that desk. There is a Raspberry Pi that's basically what we built yesterday. And that Raspberry Pi is already connected to the chat room and already accepting commands. And we can actually look at the code that's running that. So let's go ahead and look at that. Just let me put some of this on the screen here. All right, cool. And this is open source, and I think we called it Twitch RC car. Yeah, we did. Great. So now we can see that. So actually, we already have someone in the chat room that can control the car. So if you want to just type F, then the car will go forward. B, the car will go backwards. And then R and L. And yeah, you can hear the car behind me going actually forward. All right, so what is the plan for today? So the plan for today is actually to connect another Raspberry Pi that we have here with the camera of the Raspberry Pi that we have here and a battery. All right, so this is just a simple battery, and put everything on the car. So basically everything is going to be mounted up here, like so. So we'll I don't know, put this somehow, I don't know, maybe duct tape or whatever. So put this somehow and then mount this and the camera on top of it. It's not going to be pretty, but it's going to work. And then the plan is to have this and this like so, right? So this is going to be streaming to the computer. And yeah, I think that's one other option, to basically just remove this like basic plastic. And I don't know, either break it off or try to kind of remove it nicely. Which is definitely an option. So we can definitely do that. By the way, guys, if you can do like FL or something so we can see the car actually moving while you type, that's going to be awesome. All right, so you can actually see that the car moves exactly to kind of the commands that you're giving it. Now we're gonna add another layer of virtual reality to that. Stevens, if you're, oh, Fire Copy, welcome. Fire Copy, actually you are not white labeled to control the car. If you want to control the car, just let me know. It's basically just an array of users that allow to control the car. Whitelisted, yeah. So this is nice, and this is already working. And what I want to do today again is basically to connect the second Raspberry Pi, which is here. All right, to connect the second Raspberry Pi with the camera for the Raspberry Pi and the battery here. All right, to this, and then stream. I don't need to control the car. Is this like reverse psychology? All right, so this is the thing. So we we are going to put the car here so you can hear it while I do stuff. So the ultrasonic sensor is a surprise, and I am glad someone noticed. But this is going to be a bonus, so we'll see how far we can go. If we can put the ultrasonic sensor on the car, then what we're going to try and do is basically stop the car while it's about to hit something. But this is a bonus. This is we might not be able to do this today. Yeah, I mean, what I meant is a surprise. I didn't want to say anything unless someone asked, but unless someone asked, so I'm gonna connect ET's eyes basically to this. All right. So, by the way, so if anybody wants links to all of the stuff that we are building today and all of the stuff that we've already done, then I would love to send you Amazon links. Just let me know. All right, so we are in a TMUX session, and let's go ahead and clean this up a bit, like so. Great, and let's add like a Vim here and have chat commands to control the car, and then we'll say F forward R B is backwards. I forgot to see here. So then B is backwards, L is left, and R is right. And we also have FL, which is forward plus left. And here, all right, so FR is forward R. And then here, we are going to say that all right, so here, so backwards plus left or right. So this is going to be right, and this is going to be right. What do you mean ain't working? It's working. It's right there. It moved while you did it. All right. So this is right, left. All right. Cool. All right. So what do we want to do right now? So first things first, I want to connect the Raspberry Pi to a power source. All right, and let it turn on. And then we're going to find its IP. And once we do that, we can start trying to stream the video. Okay, so yeah, Jarmahan, completely agree. The thing with this car is that it's actually just an on and off. Yeah, I didn't see it in the chat, but I can actually see it here. So that's all right. No worries about that. Okay, here and then. All right, so let's give Fire Copy the control of the car as well. What is going on? All right, so then here and Fire Copy. Great. And what we can do now is restart the Node client and restart the chat here. All right, cool. So fire copy, you now have control of the car. So if you want, you can play around with it. All right, so let's not go too far overboard with nonsense today. So the thing I got the drone today, and the drone is basically the same. So there's almost like an acceleration to go up. So the thrust, you know, to increase the thrust. Fire copy, it actually went backwards now. So actually to like increase the thrust and then go up and then go down and then a little bit to the right and then a little bit to the left. So we need to kind of figure out how to do that with the Raspberry Pi. And that drone is like crazy fast. It's basically this big and it's crazy fast. So we're going to have to be very careful when we're doing it with the drone. But for now, let's go ahead and work on this Raspberry Pi. All right, so first things we want to do with the Raspberry Pi. So let's create a new file called video.js. All right, and the plan is to basically use Raspivid, and Raspivid is a utility that comes pre-installed on the Raspberry Pi, and basically use that one and then spawn a child process using Node in order to run Raspivid. And then basically from Node to activate Raspivid. All right, so this is the Raspberry Pi. This is called Drone Pi. All right, so we are going to connect to Drone Pi here. And this is going to be 123 here. And this is now the Drone Pi. So this is this Pi. All right, so the Drone Pi is this one. And the Raspberry Pi, the regular Raspberry Pi, is the one over there connected to the car, right? So you can maybe see it like on the edge there, like next to the Mac over there. So it's connected and the Mac is charging it there. There's just not enough room on the desk here. And, you know, I like to work when the desk is clear. So I just put it on the other desk because we're not going to touch it today. All right, cool. So let's go ahead and we are going to write a little Node program. All right, so on this Raspberry Pi, what I've done so far is basically just install Node. And that Node is, like the installation of Node is very simple. Basically, all I've done on this Pi is just simple setups, nothing too crazy. All right, so let's go ahead and create this video file. And we are going to say that, oh, I did VI again out of habit. All right, so let's do this and then Vim. And we are going to create video.js. Great. And we are going to say var spawn equals to require child process. And this is the part of Node that is starting new child processes. And then spawn. And by the way, this is what being used. So let me show you run golang lambda avisrel. So this is the same thing that's being used for running lambda on, you see this? So like child process, require child process, and then you spawn a child process. So basically from Node, you can do whatever you want. So then you can do child process.spawn and then notifier and so on and so forth. So you can actually do a lot of things with it. All right, so then this is spawn. And we are going to use HTTP as well, which is going to be require HTTP. All right. And then here we are going to say child equals to, and this is going to be this. So spawn of So it's capital F. Yeah, capital, all capital letters. So OPTVC raspivid here, and then we're going to supply a list of parameters. And basically we're going to say HF and then width of 640 and height of 480, and then the output is going to be to pipe. And what else do I want? So this is a random one that I saw online, but let me put that here. So this is supposed to make a low latency one, the -T99999. I literally have no idea what it does, but I tried 0, which is the default, and the video seemed very latent. And then frames per second, so we're going to put frames per second here, and we're going to put a conservative value of 20. All right. So that is cool. And then we are going to create a new server. So this is going to be var server equals to http.create server. And then function of request and response. And then here we're going to child.stdout.pipe to the response. All right, so if anyone is not clear on what we're doing here, so we are creating an HTTP server that spawns a child process called raspivid, which comes built in on the Raspberry Pi. And then basically it pipes out that child process output to the response. And then we're going to do server.listen on port 8080. And then let's do console.log. Server is listening on 8080. All right. So now let's copy this. So this is going to be what? Video.js, and we're going to copy this to the Pi here, and we'll call it video.js. All right. All right, cool. So now we have it here, and this is the window to the Pi. So we are going to say, oh, first things first, obviously, we need to connect the camera. So let's go ahead and do that. All right, and now let's connect to the server and run. Oh, the Raspberry Pi died because of this. All right, let me restart it. All right, so I'm restarting the Raspberry Pi here. So let it restart. Cool. So let's exit here, and then we should have a video here, and we do. So sudo node video.js. And what we're trying to see here is invalid expected invalid function. Okay, so let's see. We made a mistake here. So let's see where we made that mistake. Video.js. So this is function child. Where did I make that mistake? Let's see if I can get a line number. Create script. Syntax error. Oh, line 1. Child process dot spawn. Require child process. Well, this is weird. No, there is a closing bracket here. And there is everything is closed here. So spawn is closed, require is closed. And then this one, function, is closed. And this one is closed with this one. So everything is closed. And then server.listen and console.log. No, but it's saying something here like the require child process. That's what it's complaining about. Yeah, that's what I have here. Function. That's what I have. All right, so let's go here and node video.js. And let's see. So, what? Oh, well, it doesn't really get there even. Well, I can definitely try. So let's do this, and then this, and this is going to be piped to the response. But that's not the case. That's not what it's failing on. So video.js here. That's not what it's failing on. Raspivid. Okay, so now Raspivid is actually misbehaving. So let's look at video.js and try to remove everything we don't need from here. So let's take only this, and then... Oh, here. Okay, got it. So here, this should be a -o. All right, so let's go node video.js, and let's hope. All right, so again, so video.js. Where are we messing things up here? So we have a width, we have a height, we have FPS of 20, T, and then output. So let's do -b. Let's see. No, still no. Video.js. So let me copy something here. What did I miss here? Oh, I missed okay, got it. I missed one of the directories. Okay. So let's do that, and then node video.js. And now this should be listening. And now the camera is actually working. All right. So what we need to do in order to activate this, we need to go to VLC. All right. So I will open VLC here. And then I will open network. So you can see that here, open network. And I will do HTTP 192.168.123 and then port 8080, which is the port to the server. And here is the video from the Raspberry Pi. All right, so you can see the video. And I'll move the video around, and you can see the room and all my medals and the camera boom. And here's the camera above the Pi. So now I'm with the camera. I'm using a camera to take a picture of a camera. But the thing you don't see here is the video is super, super latent. Like crazy latent. So one thing that is weird is that this camera stops functioning for some reason. So I don't know why, actually. I don't know why. So let me just try and refresh this here. Like the camera above the Pi just died. I don't know why. Let me try and reconnect it. Okay, so what is going on now? Okay, so this one is working. And now this one isn't working. Something here is possessed. Sorry, technical difficulties. Let me fix that in a minute. Now, not like these things aren't working as I want them to. All right, now this is good. So let's put that here. And another one is going to be this. No, it's going to be this. Okay, great. So this is going to be this. So let's put that here and here. Okay. So you will not be able to see that, but the video is super, super latent, like crazy, crazy latent. I'm talking about like 3-4 seconds of latency. And now like cameras are just freezing here. So if this one is working, that one is freezing, and I don't know what's going on here. I really don't. So let me try and fix that, because the camera that I am on just froze. Yeah, that one is just freezing, the one above me. So this is the first time this is happening. So just give me a second and I'll try to fix it. No, something is off. Okay, so this one is here now. All right, I don't know what's going on. Like the camera that is taking showing the Pi is just not working. So can you guys now see me and hear me? Can you just acknowledge that, because like I don't know what's going on. All right, cool. So let's open up VLC again and play. And I don't know why this happened, but I literally have no idea what happened. All right, so let's restart this, like the video server, and try and run VLC again. Yeah, so you can actually see now. So the camera here, and it's latent. So you can see my screen, and you can see the camera above it, and the room, right? So, but the video is very, 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 very sketchy. Yeah, so let me do that actually. Let me go to Nightbot and edit the command. Where is commands here? So working. So let's edit this. From the chat and see where the car is going using the camera mounted on it. Today we are working on the mounted camera part. And how do I save it? All right, submit. All right, cool. So now working. Yeah, so working is the command. Great. So I literally have no idea what is happening with the camera above the Pi. Let me try and fix it one last time. No, it just doesn't work. I literally have no idea why. I'm going to try to connect it directly to the iMac. Maybe that will do the trick. All right. So now this seems to do the trick. So let's hope it's going to stay like that. All right. So again, this is the second Pi. And this is the camera on the Pi. Cool. So now you can see that the video is already working. And what we want to do now is just make the video much, much nicer. So in order to do that, there is something on the Pi that you can install on the Pi called Jpeg Server. And it's basically a very, very smooth streaming experience for the Pi. All right, so let's go ahead and do this and then install the server. And all I did is just restarted a server, right? So now I will go to 192.168.123 port 8080, and then I can go to stream. So let's do stream, and you can see the stream here. This is real time, so you can see how much smoother this is. You know, comparing to what we had before. So I can inspect this. So let me just do something here. And let's take this. My screen is too small. All right, so let's take this. All right, so here, this is going to be action equals stream. And now this is, you can actually see that. So let's close this. And this is the camera from the Pi. And you can see it's much smoother. So this one that you see on the screen right now is from the Raspberry Pi. All right, so you can actually see this is coming from the camera on the Raspberry Pi. And that web server is on the Raspberry Pi. Right, so this is here. Cool? Cool. So now, and this is my cup of coffee, my keyboard, my Mac, my screens, and so on, right? So everything here is working as expected. Here's the camera that is videotaping the camera. Okay, great. So we can actually now see that thing here. So let's do a browser source for VLC here. So let's do a browser source. All right, and then this is this, and it's going to be 640 over 480 and 30 frames per second. And you can actually see it now here, right? So great. So you're going to be able to see the car. And now let's hide it. All right, cool. So what we need to do now really is our job is done. What we need to do now is mount this on top of the car and see how it goes. Right? So let's go ahead and do that. All right. So first things first, I'm going to turn the car off because all of you guys are assholes. The car is off. I knew someone would try that. I knew someone would try that. Right. So now here. Great. And let's do like that. Okay, cool. So what I'm going to do now is I'm going to take the battery and I'm going to connect the output for the battery. I'm going to disconnect the Raspberry Pi from the computer and connect it to the battery. Right, so now the Raspberry Pi is actually, as you can see, it's portable right now. So it's literally like on the battery and I can take it and put it on the car. And now the hard part is really mounting this. Believe it or not, it's like one of the hardest parts. But we'll figure it out. So let's try something like this. So let's try something. No, this is too long. So let me show you what I'm trying. So basically what I'm trying is to put like the car like this. So let me try to do that. No, it's even before the super glue stage. Just 1 second, let me try to do that. Okay. So even before the super glue stage, there is like 3 things that need to kind of go on the car. And I'm not sure whether it's not a good idea to just remove that entire plastic part like altogether. I'm not sure if it's going to make it any easier to mount things. I'm pretty sure it won't. But we can give it a shot. We can try. Yeah, so that broke off. Great, so that broke off, and that makes it easier to put this like somewhere here. I don't know, we'll mount it here, like somehow. And then this is going to go here, and now the hard part is going to be mounting the camera in a nice way without it being in the way of anything. So let's try something like this. So this is going to go inside here. All right, so I hope you guys are with me yet, but I'm like assembling stuff here. Now this is going to go like this, and the thing is this is so flimsy, so I literally just don't know how it's going to hold here. Because otherwise it's going to really be sketchy. I think this is nice. So let's try and see how this looks. So let's SSH to that Pi again. All right, and then do that thing. All right, so now let's go here, refresh. And now the camera is working, isn't working. What's going on? Like, what is the issue right now? Did I kill the camera? Yes, I'm SSHing via Wi-Fi. Everything is Wi-Fi, like it's not connected anymore. All right, so here is the video. So this video is coming from here right now. Okay, so this is on the car already. And now the hard part is kind of putting this in a nice way without it being too flimsy. I hope I'm explaining it correctly, like what I'm having an issue with. So this I already have a place for. This is not going to be a problem. I can even put it like here, like so. So that's not going to be a problem. I can like duct tape this really. So everything here I can just duct tape. It's not going to move around a lot. But the part that I'm having trouble with is how to mount the camera in a way that is going to not be very shaky. And this is the part that I'm kind of struggling with right now. I really haven't thought that this is going to be such a big problem. All right, cool. So this is this. All right. And my lovely keyboard. So let us try this road again of putting the camera through here. Ah, this is so sketchy. All right, so now the camera goes through the pie, through the car. Come on. All right, cool. So this looks good. And then like here. Is this a good thing? Is this like a good spot? No. Like this. So there's actually bolts on it, so you can bolt it on. But I don't know what am I going to bolt it on to. All right. So I didn't expect this to be this hard, if we are honest with each other. All right, so maybe we'll do like this, and then I'm gonna duct tape this to this one. So how does this look? Let's put it here. Is this a good point of view for the car? Yeah. All right, cool. So let's duct tape this. Now I need to find my duct tape. Ah, look at this. Duct tape. All right, so now let's do this. We are going to duct tape this whole thing. It's not going to look nice, but it's going to function amazing. So this is going to go here, like so. Great. Is this a good point of view for the car? I think so. Maybe it's too high. Maybe this. Where is this? No, this is pretty good. All right. So now let's duct tape this. All right. So now we're going to duct tape this. And I think this is going to hold, really. I don't think this is going to move. Well, it's probably will, but let's duct tape this gently here. I don't want to hurt the pie. So let me try and like just hold it in place with a thin strip of duct tape. Just because I know you're gonna flip the car, so I'm just gonna protect the pie here. All right, so all that is left is to control the car. All right, people, Go ahead, knock yourself out. Just a sec. Let me put the camera here. 1 second. 1 second. I'm putting the browser source here. All right, here. Move forward. You hit a chair on the backward side. Move forward. The car is not in the room now. You guys have been fun. All right. This project is a success. I think we can safely say that this project is a success. Now it's in the kitchen. No, it's not. It didn't tip over. You have to say this is one of the nicest hacks on Twitch ever. You have to admit that. Don't tip over the bike. All right, here's the car. And the problem is the camera isn't sideways, as you can see. The camera is straight. The problem is that these shocks are like Chinese shocks. So basically this car is very flimsy. And that makes everything really, really sharp. What you see in front of you now is a dog. All right. All right. So, what did you guys think of this project? Now, there is a car running around my house. And you guys control it. Yeah, let's put the browser source here so we can actually see it on this screen as well. So I actually have no idea, not enough bike tipping. If you would tip my bike, I would literally shut down the channel. All right, so, and there is also no way you're going to tip the bike, but that's all right. Cool. So, now we have the camera mounted, and it is, extremely useful, as you can see. And let me just bring it over here. I think it's flipped. I mean, look at this. This is beauty, man. Look at this. This is a hack. Look at it. Look at it. So this is pretty awesome. Let's refresh here. All right. So as you can see, this is the car, and let me just let me just control it for myself in the chat, and you'll see how extremely accurate it is. All right, so let's do. All right, so let's do forward, and then backward, and then forward left, and another forward left. And you can see it's now in the hallway. So another forward left. And it's actually too far. So let's take it back. And I don't know where it is. So let's take it forward, right? Oh, I know where it is. Okay. The problem is that it's tipping over. So it's not like once it's just the weight of the battery, and I knew it's gonna be a problem since the beginning. the weight of the battery on the car is just like too much. So it ends up going like this. And when it ends up going like this, straight is like forward is no longer just forward anymore. So it ends up just going all over the place. But it's working. So we have two Raspberry Pis. One is, as you can see, on the car with a camera, and another one is controlling the car from the chat. Here. So that is the one that's controlling the car. The Raspberry Pi on here is not actually controlling the car. All it does is just streaming the video back to my computer. That's about it. No more than that. So that is pretty cool and pretty useful, you have to say. So now let's turn this off. And this is off, I think. Should be. Yeah, this is off. Let's put the car down here. And let's remove this. And let's put this aside. And we can actually also remove this here. Okay, cool. So everything only works in Wi-Fi range. Yes, everything only works in Wi-Fi range. What do you mean trolley problem, Shambor 7? What do you mean by trolley problem? By the way, I don't know how long have you been here, but did you see the car actually working, or did you just join? So the thing is this. It's only Wi-Fi, but if you think about it, what you can do is you can take a laptop out and you can have the laptop tether from your phone, and then you can have the Raspberry Pis tether off your Wi-Fi on your computer. Yeah, exactly, and that's it. Everything will just work just the same. And you can also the thing is you can also stream externally, and yeah, the thing is everything is limited by how much the car just sucks. So as you can see, it's just like on the desk right now, and it's literally on its side because of the weight of the batteries. So maybe if I even take, just maybe a better spring here, maybe that would work, because this is really, really kind of lightweight. So maybe even just doing that, or even just replacing this with like something hard. So, just a piece of plastic or just a piece of metal or something like that, just to not have those move at all. Maybe that's even going to be better. But right now, the thing is, the car, just by the weight of the battery on it, it just became literally 3 times as heavy. So those flimsy shocks, they are just not able to handle it. But this thing is really amazing because it can literally just power the Pi for over an hour with no problem at all. So this is pretty awesome. So let's put this here. And it's off. Okay. Cool. So what I wanted to do is I wanted to connect this one, which is just to make it like avoid obstacles. But I don't know if we are gonna be able to do that. Because then I'm going to need to mount another thing on the Raspberry Pi on the car, and it's like already on its limit. So we will see that. So Shambor 7, if you're still here, I would love to answer your question. I just don't really understand what you're saying by the trolley problem. And other people around here, if you have questions, please let me know. I don't know how often you see a car controlled by the chat room like this and streaming the video of it. So this is a pretty nice hack, and it's pretty cool to see. Okay, cool. So now we can see that we have the video, and you see how smooth and real time the video is. And it's actually streaming at 1080p, so it can stream at 1080p. And yeah, right now there is no light around the house, but you can take it outside and just make it just run. So let's see what's happening on Twitch. I think this was pretty amazing for the duration of the project and the amount of code really to wire everything together. So yeah, there isn't a lot of code here. There really isn't a lot of code, and everything is, you know, basic Node.js stuff. The thing is just making the circuits work and just like thinking about everything and connecting the Pi to the network and just generally understanding what we want to do. So fire copy, how long? 2 streams. So 2 streams, about I don't know, about 5 hours, I would say, 5 to 6 hours. And I didn't work on the project off the stream at all, so everything was in real time on the stream. Yeah, it's pretty cool. I think about 5 hours or something like that. You know, obviously there's a bit more time with like ordering from Amazon and stuff like that, but yeah, about 5 hours. I'm not messing around here. I'm not playing games. All right, so now what we want to do really, Twitch. You got any good recommendation of reading materials about connecting the Pi to the computer? So again, you know, for me, it's the flow is always the same. For me, the flow is always the same. It's I just need something, and then I solve my problem. So when I needed to stream video, I just Google how people stream video. I noticed there is this Jpeg thing, and I need to compile a bit of C. But again, just following really simple kind of steps. So there is no reading material, just like read through every problem you have. Like, how do you SSH? Then Google, how do you SSH into the Raspberry Pi? And then you're going to see the solution, and so on. It was a joke about self-driving cars. There is a thing called trolley problem, a thought experiment about normal choices that can be applied to self-driven cars. Of course, this doesn't apply here. Okay, got it. Got it. So Shembor7, one question to you though: did you see the car in action, or did you just come in and miss the entire like fun? Because if you do, we have to show you. You know that. The moral choice of crashing into the bike. The moral choice of crashing into the bike. So you saw it. Great. Awesome. So yeah, that's pretty cool. I mean, I really like the way this worked. The video from the camera can definitely be better. If it was lighter or anything like that, then it would definitely make the entire experience much nicer and much easier to work with. All right, cool. So then this is this. And let's go ahead and open source this shit. And then Twitch RC car. And then let's do this, and then git init, git remote add origin, pull origin master. And video. Time to duct tape on a flashlight. So we can definitely duct tape on a flashlight. I don't know how much difference will it make. I'm game. I am game to test it out if you guys are into it. So let's do it like this. So the light is under the camera, and one more thing is like maybe the camera should point a little bit more down because it's pointing up. So let's do both of these. All right, so let me try that first. And again, the car is really kind of squishing around, but I don't know if there is a lot of things I can do about that. So let me try and mount the flashlight on. And let's do that. A lot of duct taping today, a lot of duct taping. All right, cool. So let's do this. And let's add another one. And let's take the camera and give it a little bit of downward facing. Okay. All right. So this is what the car looks like now. Okay. Right. So let's do this. And let's see how that works. And I will answer the question in the chat in a minute. Just 1 second. Let me see what's going on here. All right. So let's put the car there, and let's activate the video. All right, so now this is here, and let's go here and put this here and refresh the cache. All right, so go ahead, have some fun. You guys have control now. Go ahead. What headphones do you use? Wireless SIM convenient. So the headphones are actually pretty good. Let me find a link to that for you. And let's put the browser here as well so you guys can see that and refresh the cache. All right, so this is where the car is right now. Let me put it here. Okay. So let me find you a link to those headphones. So I'm looking at my Amazon orders, and I'm going to give you a link in a second. Where is it? There it is. All right, cool. So those are the headphones I use. Right. So now, Twitch. By the way, your GitHub profile makes me feel the same as when someone I know meets me on the street, but tries to avoid making eye contact. What is my GitHub profile? Literally, like, didn't change it in like a year. Even more probably. Oh, you mean this one? Okay. How do I fix it though? All right. Cool. So this profile picture, got it. I'll change it. Thank you for letting me know. Thank you for letting me know. No, no, that's okay. That's okay. I know you have good intentions. I know you have good intentions. That's okay. That's okay. All right. So where was I? So let's put this thing on here. So git commit -m and then working car with the Twitch chat and video streaming. Git push origin master -u. And now let me do that and put it Twitch RC car. So there is the link to the GitHub page. And you can check it out whenever you want. MIT, you guys can go ahead and use that. What I want to do is remove all the usernames from here because we don't want that on GitHub. All right, cool. So now we have that one, and this is on GitHub. Okay, so now it's 8:40, and the car is there, and let's yeah, you see it's like it should go back, but it's actually going back and left, and that's because of the shocks. Yeah, you see it's like all over the place. Yeah, it's like it's not even going straight, unfortunately. And that's all because of the shocks. All right, so now it's 8:40, and we have a little bit of time. So no, that's it. The car is stuck. How shocking? What is shocking? No, that's it. The car is stuck. Oh, there it is. It got unstuck. Ah, shit. Oh, got it. Okay. Sorry, I'm like missing all the puns today. I'm sorry about that. Oh, this is pretty awesome, I have to say. The only problem is like how the car functions. Ah. All right, so to be honest, really the only limitation here right now is this. It just basically ends up all over the place like this, and then when you say forward, it goes forward and left, and when you say forward and left, it just goes almost like 90 degrees, and that makes everything harder, and it just makes the experience suck. So, but unfortunately, that's the case, and I'm gonna have to fix it. I think what I'm going to do is I'm just gonna cancel out the shocks. I'm just gonna grab a piece of something hard here, and just like put the car, just like almost like a very very hard shocks car. Twitch. Lol, it is like one of those 2-button kiddie cars, 1 button forward, 1 button back, plus left. Yeah, exactly. Maybe that would have been a better to start with. So it's actually with the camera off the car, it's like completely changes the dynamics, completely. And let me just turn these off, and this off. Okay, so with the pie off the car, the dynamic of like how the car moves really changes, and that makes the entire experience much better. But the whole weight here just like is too heavy for the car. It was really built to support its own weight, unfortunately. So there's not much I can do about that. What I can try again is just to cancel out the shocks altogether, and that will probably help a lot. So I'm gonna measure that and then try and just like put something there that is hard, and then see how that works. But I think it's a too much of a modification for $28 car. Okay. All right. So again, we are at 9 p.m. So we have a little bit of time, and a little bit of energy left. So you guys either, we can have a Q&A, or if someone wants to work on a project or code review or anything like that, we can certainly work on that and see where we go. So let me know what you guys prefer and what you want to work on. And if no, then we're gonna say good night. And this was a pretty good project, to be honest. I have a Golang script, needs some help. What is your Golang script that needs some help, Stevens? What do you need help with? What do you need help with? What's the Golang script? Let me post it. All right, post it. We are waiting. All right. So, by the way, this is the entire code to control the car from the Twitch chat. Fire copy. Fun fact. Was working on an online job application. I put on too many skills and it kept truncating the skills I had. So this sounds very familiar to me, and that is why I don't like applications. They just like tend to reduce you down to the numbers and reduce you down to like stupid shit. Shambor7, Kenso Dev, any favorite new trend in programming? So I don't know. I think functional programming is really nice. I definitely find myself enjoying functional programming. SSH IPS. Get list of public DNS of EC2 instances. String EC2 and then exec.command output. Oh, got it. I know what you want to do here. I know what you want to do here. Oh, man. I don't know if that's the right way to solve what you're trying to do here. So let me dial you in on Skype and let me help you. Fire copy. Well, wait a second. We're waiting for Stevens to pick up. If he's not picking up, I'm not dialing again.
The person whom you're trying to reach is currently on.
Okay, so fuck it. When would you use an Arduino versus a Raspberry Pi? So Shambor 7, how much do you charge on Skype help? I don't. If you want to do it on the stream, I don't. When would you use an Arduino versus a Raspberry Pi? So I actually have an Arduino, and I also have an ESP2866, which is the Wi-Fi module, and I honestly I don't know. And the thing is that for me, the Arduino is better for simple circuits kind of things. Like for example, based on some input from a sensor, then do some output into another sensor. So really simple kind of circuits that require basically one function. That based on some input is gonna have some kind of output. So again, what I did with my daughter, for example, we created a photon meter, and then based on the amount of light in the room, we either turned on a LED or turned off that LED. So for me, the Arduino is really for those kind of things. Simpler stuff, definitely simpler than the Raspberry Pi. For the rest, I definitely prefer the Raspberry Pi. But we're going to have some Arduino on the stream. When my daughter is back from vacation, we're going to work a lot on Arduino. Shambor 7, how much do you charge on Skype help? Like I said, I don't. The part of the Q&A here is to help people. That is why we usually have 15 to 20 minutes at the end of the stream, and we sometimes have dedicated streams just to help people. So I don't charge anything for that. Stevens, wait, no man, I dialed you in. You missed your shot. Enough stuff. I read recently the best Raspberry Pi is an old used cell phone minus the GPIO. So here's the thing. I thought about it when I wanted to stream the camera. I thought about like taking and here's the thing. I'm an iPhone user, right? And I thought about taking the iPhone, like putting it on the car and stuff. But the iPhone, to be honest, is not really meant for that. I would maybe try and do everything on to be working on an Android, like an old Android phone, and for that it's great because Android has much less limitations, yeah, so definitely if you don't need the GPIO and you just need, hey, based on some location do something, and based on some, I don't know, like use the accelerometer, do something else, definitely I would use an old phone, 100%. You already have battery, you already have GPS, you already have a camera, you already have connectivity, you already have all like a lot of stuff that literally for the Raspberry Pi, look at what you need, right? You know what I mean? So think about it. This and this is like in one device, which weighs like a third of the weight of this thing, so if there was just a phone here, mounted like this, it would be much nicer. So that's definitely, again, I'm an iPhone user, but with an iPhone it's not easy. Definitely like an old Android phone is gonna be much nicer to do it with. You're gonna have to work with Java or maybe Kotlin. I don't know if it's supported in old Android phones, but it's not a big deal. I mean, code is code. It doesn't really matter. It's all syntax at the end of the day. So it's not going to be a big problem. And really, if you plan your steps correctly, it's not much more expensive than just a Raspberry Pi. Definitely not more expensive than a couple of Raspberry Pis. So Fire Copy. I have an iPhone because I use FaceTime a lot. Why do you use an iPhone? I don't know really. I definitely don't use it as a phone. That's for sure. That's for sure. So I do use FaceTime with my kids and my wife a lot. But other than that, I don't know. I just don't like Android. I just don't like how everything is built there. As an engineer, like if I want to hack on something, I would get an Android. But as a user, I wouldn't. And that's the reason why I'm working on an iMac here, and I work on a Mac laptop at work. I just like the way the Apple products just work. And yeah, sometimes it's stupid. I mean, with the iPhone 7 and the removal of the headphones jack, yeah, it's stupid. And sometimes, working with Apple and using Apple products is frustrating, but yeah, a lot of the times it's a joy. All right, so are we gonna forgive Stevens and try and dial him again? So cough Samsung. Yeah, people from work are also trying to convince me. About yeah, let's give him one more shot. So look at this. I am dialing him in. If he doesn't answer, that's it. All right, look at this. You can hear it dialing.
What? I answered.
Okay.
Like I had technical difficulties, man.
You're such an asshole. All right. What do you need help with?
Yeah, it's gonna be quick, but thanks a lot. I really had technical difficulties.
Access denied 07. Thank you for the follow.
So can you hear me?
Yeah.
Yeah, so if you look at the Golan program, what I'm trying to do is really simple.
I know what you're trying to do.
Right, I'm trying to just get like a list of machine name and the SSH public DNS name, right? So just for my own convenience. So this like already works the way it is. Like, well, it works in a way that I can get the data back, right? But I'm stuck on trying to work with the response from AWS EC2 describe instances, right? So that thing is a string, but then I want to transform it into a much simpler data type where I can, use. And then the part I'm stuck is like, if you see on line 34, like JSON on Marshall, like that doesn't work, right? And then like I'm just like stuck at this area. Like, should I use like a structure, and then how do I like parse it, and what's the best approach? I mean, we don't have to finish it here. I guess I can use some hint of.
So what is instances list?
Well, if you look at instance list, it's like at the top I created like a struct, which is incomplete.
But EC2 describe instances doesn't by default use JSON.
Exactly. Like what I get back is just bytes, right? And now if I do if you look at line 31, if I do results equals a string out, I do get the result of the
but you're not getting JSON. It has nothing to do with Golang here. This has to do with like the EC2 command line.
Right, but it's a string. Like if I print it out, it's a string.
It's
right?
a string, but it's not a JSON.
right. I need to be able to convert it to a JSON so I can convert it to another
so
data
you do
structure.
EC2 dash help, and then EC2 help here, and EC2. No, you're working with something else. Why aren't you working with like the Amazon thing here? So EC2, there is probably dash output, and it's gonna be JSON like so. And all you need to do is just do that, and then you're gonna have JSON, and you're gonna be able to parse it. So let's see, EC2 command line probably has output, and because this is like EC2 is the old one, but okay, let's do that. All right, so let's do the command line here, and then output. Yeah, so you can have output here. Output returned by AWS service is shown beneath user input. Okay, so then, format maybe, dash format, JSON. Okay, there it is. AWS EC2 format. So just try and play around with it. And because I don't use EC2, I use AWS. I don't use EC2. EC2 is old. I use AWS. CLI.
So you mean there's a way to get like JSON back directly?
Yeah, for sure. So you can do AWS EC2 and then describe instances like so. And then let's do dash profile default. Man, what's going on? Validate provided access credentials. Yeah, I don't want to do this thing. So definitely, your problem is this, okay? So your problem is that all you're doing up to here is good. And everything you're doing from here is also good. Your problem is here. So EC2 describe instances returns a table. So it's basically return instances, I don't know, like instance ID, and then like this name, and then like this, and then IP, and then like this. This is not serializable.
Right.
So
yeah.
So what you need is so let's do AWS EC2 describe instances dash profile development. All right, so you see this is going to output a JSON because the default format for me is JSON. But you also have, if we do help here, you also have a format or output or something of that nature to show how you describe the output. So yeah, output, you see here? So you can have output text. So then you do dash output text, and this is the way you probably get the result, like this.
It's a text. Well, I got it as a text.
Yeah, and it's bullshit, right? It's like it's not usable for you.
This is not that I got. I got it as a JSON. Like no, I got it back as JSON for sure. Like in a key value structure, but in Golang,
no way.
I didn't get a.
No way you got it in JSON. So
no, I'm
print.
serious.
Okay, so print that command. Okay, take that command and print send me on the output of it on Slack.
Yeah. No, I can
do it now.
Yeah. Okay. Like the output of the whole thing.
Yeah, just a sample of something.
Okay. Yeah, that's a JSON.
Okay, so do you have JQ?
What's JQ? No, I don't know.
Do brew install JQ. What I'm thinking is, okay. So wait a second.
I have.
So this is you're not giving me the full output.
Yeah. Well, it's huge. Let me give you just one instance.
Give me the first like 20 lines.
Okay.
First 20. Give me the first 20 lines, and then I will show you what you're doing wrong. Okay, so let's see here. Instance list string. Ah, dude, come on, man. This is not how you do things. Okay, so this is all wrong. Okay, so can you send me like in a file the output? Just save the entire output to a file. You can do ec2 describe instances, and then you can pipe this into a file.txt, and then send me this file.txt. I'm going to show you something. All right, so now let's go to code, go src github.com cancel dev, and let's make dir-p Stevens help here, and then cd Stevens help, and let's do that, and let's do main.go. Okay, yeah, let's go. Send me the file.
So what do I do? Do I need to echo it to a file.txt?
No, you need to pipe it. So like I just showed you that on the. All right, so you do ec2 describe instances, and then this and file.txt.
Oh, okay. Well, I'm waiting for the thing to show up.
There you go. I sent it to you on Skype. All right, send me the file, and then we're gonna do something.
Okay, I'm sending to you now. Move file.txt.
I'm basically aging right now.
Yeah. I'm not as fast as you are, man.
No, I'm okay. I'm like I'm just aging here, slowly.
Age slowly. Just,
wrinkling around. This is raw. It is raw. All right, cool.
All right, so, I sent it to you.
So let's go ahead and save this. Ah, shit. I fucking Slack. So how do you download this with Slack? So let's do download. Great. And let's move downloads file.txt to here. And let's cat file.txt. All right, so this is JSON. Okay, and if we look at this JSON file.txt, we have reservations, and inside of reservations we have instances. Now the problem, and you know, I told you that many times. The problem is Golang is not the very best language to do things like that. But anyway, here's what you need, right? So you need a way to do this. So you're gonna need a struct. Struct for reservations, right?
Mm-hmm.
And then you're gonna have
yeah, that's the structure.
Right?
That's the most important part, the structure.
So then here you're gonna have instances, and this is going to be a list of instance, which is going to be a JSON of instances, like so. Right?
Yeah.
Why are you guys like talking shit about me? Shit, I just like saw the chat and people are like talking shit about me. Why are you talking shit? He's merciless. No, I'm not. Shit. Just like anyway, I'm not Gordon Ramsay. One Zelt, shalom. Can't tell if this is a solo Twitch persona or his normal job. Co-workers enjoy this type of interaction all the time. Shit. Wow. Your bedside manner leaves a bit to be desired? What do you mean? My goodness. Oh my God. All right. So here's the thing. You need to take every every node in your JSON, and then you need to parse that into a struct, right? So the Amazon, the way the struct work is basically this. So you have reservations, right? So reservations, and inside of reservations you have instances, right? And each of these can be multiples, right? So you have this and then this. So you have to take that JSON and parse it into its own struct. So the reservation is going to have an array of instances, and that instance is going to be a JSON, and then you basically parse that into it, right?
So you mean I have to kind of like come up with the JSON structure of the entire response and kind of replicate that?
In struct, but you don't need everything. You just need what you care about. But you have to start from the top and then go to the bottom for basically what you want, right? So if you want so let's take the file.txt here. So you need reservations, which is going to be your first item. And then inside the reservations, you're going to have instances. And inside instance, you're probably going to have the IP address.
Yeah.
Right? So you're going to have this public IP address. So you can actually take that and parse that, right? So then you're going to have this and main.go. So you're going to have like Amazon response, which is going to be your first struct. And this is going to be reservations, which is going to be an array of reservation. And the JSON is going to be reservations. All right. And then here, you're basically going to have the same thing. So this is reservation. And it's going to have instances, which is a response of type instance, and then the JSON is going to be instances.
And I have to do that down to like the lowest level of the key value, and then try to.
Yeah, and then you're gonna have like a type that is instance struct. And then the instance, you're going to have like a public IP address, which is going to be a string. And the JSON is going to be the same as this. So public IP address, right? So then this will parse nicely into what you need. But you have to, but you have to get into a habit that you cannot parse a loosely typed object into a strongly typed struct, right? Mm-hmm. So a JSON is a loosely typed object. You might have reservations, you might not have reservation, you might have instances, you might not have instances, and so on and so forth. But when you parse it into Golang, you have to specifically say what you want to parse into what. Right, so you have to follow that funnel down of the JSON, and then parse it this way, right? So you've done everything good except the struct. So this is I don't even know what this is. Like list, string, JSON list. This is not what This is nothing.
That's what I wanted for, like, what would I do when I finally print it out on my command line, right? Like, that's the data structure I want to present. It's going to be like just a flat structure, like machine tag name, and then DNS name. That's it. Like, if I have like 10 machines, right? I just want 10 items. Every item has 2 keys, tag name, DNS name, right?
What do you mean when you print it out?
Well, because what I really want is, because describe instances give me like a gigantic hash with a lot of data, and what I want is only the machine name paired with a public DNS name, so I can SSH into the machine.
You
right?
don't,
Let's say,
but you don't need Golang for this. You can use JQ for that.
yeah, but I just pick Golang for it just for the sake of it, you know. It's writing code.
Yeah, but I mean, writing code for the sake of writing code is wrong. You have JQ and you can use JQ.
So what does JQ do? It's okay. I'll look into it. It doesn't matter. Anyways, that's good. Like, do you think you can post it on Gist of what you just did? And I'll just follow down that path.
Sure.
No, this is good. I think I kind of get the idea how to work with it. And yeah, you can just put it in that Gist that I sent you.
Okay, cool. All right, so let's see who's still talking shit about me.
Thanks a lot.
I literally can't suggest anything to my office mate. I have to wait till they ask me for help. Change jobs, depends on the organization, also depends on your role. Then they make me not give the answer, just pointers to where they can oh man, this sounds exhausting. Shit. This is exhausting. Kenso is a lead. He wouldn't be doing this to other leads per se. I don't do that with my other coworkers either unless they ask for help. Yeah, Gist is like a paste bin. Just as a first timer, I didn't know what to expect. Never used it. Okay, got it. So enough stuff. I don't really know what I did to piss you off. But I would love to know what I did to piss you off, because that wasn't the plan. All right, so I literally have no idea what I've done. Like, literally no idea. Astrobot 314. Yeah, Kemzak, I know. It's like it was a debate. No kiddie gloves. Okay. So you're missing context. Okay. You're missing. I think you're missing crucial, critical context. Okay. So Stevens, the guy that that talked to me, we're literally like friends. So this wasn't like our first conversation, or our second. I was his tech lead for 2 years and change, and you know, he basically grew under my leadership. So I know how to talk to him, and I know what motivates him, and I know what kind of tone I need to take with him in order to get him to understand something, and Obi-Wan. So he has the high ground. No, I don't have the high ground. That's not what I meant. So you know, it wasn't like our first conversation. It's not the first time I jump on a Skype call with him, or the first time he's on the stream. So maybe that's the context you're missing. Not that I deny being an asshole. I just have this different style, I guess. And no, I don't take bullshit lightly, man. I guess Stevens can take it. Yeah, he can. He's a good dude. So I hope I hope you understand. Where am I from originally, or where am I from right now? No, it's not about proving. It's not. It's not about proving. It's not. Originally I'm from Israel, and I think we have another Israeli guy in the chat room now. I saw him like write in Hebrew a few minutes ago. So yeah, originally I'm from Israel. I relocated to the United States in 2015. How do you feel about Israel dominance in cybersecurity? So a lot of people ask that question, and that question, you know, I remember a VC's answer for it. There is a famous VC from Israel. I'm not going to mention his name because it's not going to tell you anything. But he has a VC firm called Aleph, and basically someone asked him once, like, what do we need to do in order to replicate the success of Israel in like the high tech field, in like why is it called a startup nation? So he said, yeah, you can easily do it. Just buy a country named Israel, and that's the only way you're going to be able to replicate that. I may agree with that or not. It doesn't really matter. But what I'm saying is this. When you have 21-year-olds, right? When you have 21-year-olds coming out of the army, and they did 3 years of just high-end stuff, you know what I mean? Just like crazy stuff. You know, like, man, you know, like, I don't even know what these guys do, right? I wasn't, by the way, I wasn't, when I was in the army, I wasn't in computers. But basically, you know, like, you have 21-year-olds coming out, and they already did 3 years of basically 24 hours of work, right? So, you know what is required, and you know what companies need, and you know what the you know the Office of Defense needs, and so on and so forth. And this is why, you know, Israel is leading, because it just has this supply of just brilliant minds coming out and just looking for things to do. So that's what happens. Yeah, and enough stuff. Again, dude, it's like, it's not about proving. It's just about, I don't. So, you know, it's been my approach all the time. If I, you know, it's like, if I want you to get insulted, then I don't mind if you get insulted, but I really mind when people don't understand my approach. Like, I wasn't trying to talk anybody down or insult anybody, you know. So it's like, so when I do that and then I come off as aggressive, and I didn't mean to come off as aggressive, then it bothers me. But I guess it's just, you know, the way I talk, and I don't know, whatever. But yeah, definitely didn't mean to do anything insulting here. Okay, so Kamzak, any more questions? Jarmahent, what do you mean? What the WTF? I just mean, okay. So I think we have answered all of our questions right now on the chat. So it's 9:20. We have a little bit more time, so let me know if you have any more questions. And I would love to answer those. Yeah, code review. Let's go ahead and do that. Let's do a code review here. So is this the one for the CI? The Python CI for Circle CI? Okay, so let's go ahead and do that. So const. Okay. And then this one. So why? The first thing that jumps to mind here is why do you do this? Like follow project.content. What I would expect is to get back typed object. So yeah, I saw what const is. I would expect to get back typed object here. So you would parse that JSON and send me back like object. Yeah, I don't care about the printing actually. Okay. Oh, got it. So you're basically not there yet. Okay. So you're not there yet. So if in case you're not there, if you're not there yet, then that's fine. So let's do recent builds. Recent builds is API path, and this one dot format VCS type username project build name and self dot token, and then you do this one. Okay, and then add user, which is self, and then you do post self dot token. So where is this post? So the post const. So you get requests. Okay, so request. Oh, got it. So you basically add the token in the API path, and then the init gets the self and the token. That's great. Okay, great. I like this already. I don't like the naming, but that's okay. You can change that. And then is API path. Okay, this looks very good. This looks very good. What I would do here. No, you don't in Python, man. No. Yeah, I know what it stands for. It's just like weird to type it. That's my only thing. I would literally call it Circle CI client, or Circle client, or something like that. So Python is very similar to Ruby. In Ruby, you do x equals something, and if you do x equals something, then this is a constant. This is a variable, and this is a constant. So if it's capitalized, then it's a constant, and if it's downcased, or then it's constant. So Jarmahan, to kind of sum up, it looks good. It's very basic yet, but it looks good. Yeah, but again, just to understand, what I would expect is to have a project which you can literally have as a named tuple, and then you don't even have to create a model or something like that, and then you create that project from that JSON. And when I work with like, I get I don't know, projects equals to ci.get projects, and then quargs here. What I would get here is for projects in projects, and this is Python. So here you would do project name, right, or something like that. So that's what I would do. What do you recommend? Oh, wait a second. Did I miss a question? Fire copy. Fire copy. I saw your question, but I missed it here. How do you stay fit? I ride bikes and I race bikes. That's it. That's about it. I do anywhere from, I would say, 180 miles to 250 miles a week. and usually Tuesdays and Saturdays are riding with the race team. So that's basically balls to the wall, and just like you're on the rivet the entire time for 80 miles or 50 miles. You just finish that ride and you're just like, you're done. And I just like watch very carefully what I eat, and how much I sleep. And I don't eat junk food. I don't drink sodas. I don't consume sugar in stock amounts. And I eat a lot of vegetables and a lot of fruit. Okay, so I'll think of a better abbreviation. Circle CI client. I like the Circle CI client. With things like that, you're just typing it once. Don't forget it. You're just typing it once. You're saying client equals to Circle CI client, and then you pass the token, and then you can say client dot something, client dot something. So don't think about making it short. Make it descriptive. If I see CCI saw in my project, I don't know where it is. I want to see Circle CI client, and then I can know immediately what this thing is. If you think about it, when you use 50 libraries or 60 libraries or 70 libraries sometimes in a project, you want to look and see what that is. What do you recommend for error handling for open source projects? Would you like to tie it automatically, create an issue on GitHub to submit exception stack trace plus other useful info without requiring GitHub account, and also not submitting too much, invading privacy? Project is not net. So here's the thing. I have quite a few open source projects, and sometimes I'm really frustrated about the way people submit bugs. It's like, hey, it's not working. Dude, I mean, just give me something. You know what I mean? Just give me a little bit. So I definitely wouldn't automatically do that. But what we do, like for example at work, what we do is we have an issue template for everything. And then it's basically show me ways to reproduce, show me ways to do this, and show me ways to do that. And then when you submit the project, when you submit the issue, then you need to include everything. Otherwise, it's like it's getting too much to handle. Sentry has plugins, integrated GitHub, I think. Again, I wouldn't do that. I definitely wouldn't do that, and I would not use a library that automatically does that as well. So my approach would be, if your question was to automatically do it, I would definitely not automatically do it. Sometimes you need to slap a global keyword on, usually not a good sign. Have you used immutable JS? Yes, I have. Yeah, I know, no Python really. I mean, I can read it, but I don't know the syntax. Python is great. I love Python. How am I supposed to ask for the JSON object again in Python? So I think I think this like dot content is JSON. So you just need to parse that JSON and parse it into no, Python is not plain English, that's for sure. But it's nice. And then you just parse this into an object. Yeah, it's a very friendly language. Any recommendation for a beard trimmer? I just use I don't know, something basic. I don't even know what it is. I don't remember the name of it. But I hate shaving, so I just like trim it. Compared to other languages, German hence stretching it. But I think it's a good interview language, for example. I like Python. I have to say I like Python. Python is really, really nice. I don't know if I would call it interview language, but it's really, really nice. Again, I said it many times on the stream and off. JavaScript is taking over. As an engineer, currently living in the world, you have to know JavaScript if you wanna be relevant anytime soon. So yeah, that's the deal. All right. We're getting closer to like 9:30, so let me know if you have any more questions. If you enjoy the content and you like what you saw, then if by the way, who here in the chat room did not see the car moving with the chat? So who did not see the car working with the chat room? Who did not see this being controlled by the chat? Yeah, I got the camera working. 27 lines. You didn't see the car. Astrobot 314. Thank you for the follow. Come on, man. You're missing all the fun. Shit. Let me show you guys, okay? Yeah, I got it working. What do you think I am? Of course I got it working, man. All right, so let's do this. All right, so this is the car. And again, this Raspberry Pi is only streaming the video. And the Raspberry Pi over there is the one that's actually controlling the car. So let me turn the camera on for the car. All right, so who wants to control it? 27 lines in Astrobot 314. All right, so let's do open source, full stack network. The car is moving right now, but let me just control the camera here. Twitch. Where is it? There it is. Just a sec. Let me connect the car here. And then I can connect the video as well. All right, so now let's put the video on. Here is the video from the car. You can see the video. The car is there. So someone has control of the car. All right, now it's here. You see? It's my Superman socks. Okay, so now, so Astrobot 314. Let me give you control of the car, and you'll be able to control that as well. 314, and also who was it? Fire, someone. 27 lines. 27 lines. 27 lines. So I was walking the dog. That's the reason I'm wearing shoes. I don't usually wear shoes around the house. Right, so that one to go to the client. And let me restart the client here. All right, so now you guys can control the chat and the car. So let's bring it back and forward and backwards right and forward left and backwards right and forward left. All right, just so you will see it in real time. There is the car. over there. So you can see what the car sees and also the car. All right. So you guys see the car and you see the camera from the car. Oh, you scared my dog. Let me take it back. You can go wherever you want. All right. So, where are we now? The dog is here. She's like right there under my feet. Like I said, I took the dog out and I just didn't remove my shoes. That's it. No, nothing to really think about, guys. I don't normally wear shoes around the house, but let's take it away from my legs. All right, cool. Okay, so you guys were really distracted by my shoes. You guys are just jealous of my Superman socks. All right, let's do this. That's okay. TFW? What is TFW? TFW. Yeah, the car is really like the weight of the battery on the car is really heavy. So it makes the car kind of not go sock view. Not go directly to the correct place. All right. You enjoy that view for the door. Oh, that's it. The car is dead. Flip. You can't. Well, you can't deny the command worked. Let's take this car outside. You know what I can do? Let me just do something. Just a second. All right, the car is outside, but it's too dark. So that's gonna be a problem. Yeah, you can't see anything. Yeah, you can't really see anything, but the car is outside. Yeah, I don't have a pool, but okay. This is a. All right, let me grab it. Okay, so here's the car. And accession project. Add ability to type in geo coordinates with 100 yards and drive it the shortest. Yeah, definitely. Definitely. That's a good idea for the project. So that's definitely a good idea. And you can see the car, like the way it's mounted and the way it looks. It's really not anything complicated. And it's just duct taped on. So you have the flashlight here and the battery here and the camera. So this is the camera and this is the Raspberry Pi. And again, just to so what you found is just a bucket, like a sand bucket for the kids. Just a little black bucket where they just move things around and play inside. So have you done any simpler project with the Pi or something like this? No, this is my first project with the Raspberry Pi. This is the first time I ever held a Raspberry Pi. And the first time I ever did anything with the Raspberry Pi, so this was the first project. And why are you guys like? Is it like the way I pronounce flashlight, or is it like what are you like? What are you guys even thinking? Okay. By the way, 27 lines. The code is open source. I'll say Torch. Okay. The code is open source on GitHub. I'll say Torch. Okay. The code is open source on GitHub. No, I wouldn't Google that one. I know. I am aware of what the flashlight is. And I will say a torch. Great. So 27 lines. The source code for the car is above you, and there is the source code for the video and the source code for the client, which actually processes the commands and puts the things to the puts the signals to the remote control. So the Raspberry Pi that's actually on the car, like I mentioned before, isn't actually controlling the car. It's just controlling the camera. And there is the Raspberry Pi over there that you probably can't see there. So that's the Raspberry Pi that's actually controlling the remote and actually moving the car around. Just so we'll understand, so when we do F here, that command goes to that Pi, which then sends the signal to the remote control of the car. And then the car, Raspberry Pi, just sends the video. All right. And let's do that. So client, and then here and here and here and here, and then this is going to be this, and then this is going to be const. No, that's not what I wanted. So this var is going to be const. Great. And then here and enjoy. And let's do that here and that and that. Imports. All right, now you're happy. So is there a certain range the car has to be in? So 2.4 gigahertz plus Wi-Fi. So I don't know, about probably 30, 40 meters, maybe even more. But if you think about it, you can also tether from your mobile phone. And if you do that, then there is no range. You can take it wherever you want, because all the Raspberry Pi needs is Wi-Fi. And you can get Wi-Fi from the phone, tethering. So wherever you have internet, you can take that car. The video is probably not going to be as smooth, but in terms of like the commands from the chat, they're going to come in and be really, really smooth. So that was a fun project. That was a very fun project. We built all of it on the stream, by the way, together here. So definitely a pretty nice little kind of project and hack. All right, so okay, so now we are at 10 minutes to 10. So this is where we usually cut it off. And if we have any final questions, then please let me know. So all right, so this is this, and now this looks better, acidic mushroom, and yeah, let's look better. And I'm gonna add a README to this. I will try again. Try again what? What will you try again? Oh yeah, okay, got it. Let me try this one. No, that's not the one. Where is that link? All right, so post it again. Okay, here. I had a question about open source error handling and integration into GitHub. Okay, so error handling, error loading destination database. Oh, got it. Okay. Line 29. Yeah. So here's my question. No package JSON yet, acidic mushroom. I'm gonna make this nicely library. Don't worry. So my concern with this would be a couple of things. One, the way that the network setup works for us, for example, is this way, right? So all of our services don't even have access to the external world. So the external world can't have access to them, and they can't have access to the external world. So that is something you have to take into account, that the network might be blocking this. So you need to check, you need to understand how do you want to send that information, and how do you fail to send that information. Again, it goes back to me, it goes back to a basic thing. If there was a library that does it, I would not use that library. But yeah, I see it. It's like just a stack trace when an error happens. Nothing too crazy or too complicated. But again, just by exposing my directory structure just by exposing my machine location and the external IP and my network gateways, I would definitely not like this being inside inside my project. And yeah, I understand that this is there is the link to the code. It is a pop-up in the GUI to cut paste into an issue manually. Yeah, so again, that's good. If you have that in the UI, then you say, hey, paste the error message that you see or something like that and send it. That's fine. You know, that's also like what Apple does. Would you like to send the error to Apple? Would you like to send the error to Google, and so on and so forth? So in that case, if it's a GUI application and you say, hey, something happened, do you want to send the request? Do you want to send like the details of what happened? And then you say yes, then that's fine. But in the library, I don't know if I would have liked that so much. And again, I don't. Yeah, send report. It will create a GitHub issue for sure. So I don't know how much privacy concern I would have with the GUI application. You know, there really isn't a lot. It's just maybe IPs and stuff like that. Probably some companies, if you want to use it, probably some companies will say, hey, if you want us to use it, we want you to turn that off. It's just a block, and to me that would always be the case. It's like I would just not use it. So you need to understand like what is the value it's giving you, and what is the disadvantage that you're getting because you're doing it. To me, this is the cons are winning here, and not the pros. So I wouldn't use it, but this is a good start. If this gives you enough information to you know, to debug something, then this is a good start. Yeah, send report and then create GitHub issue. Yep. 100%. 100%. All right. Any other questions before we go? Because it's 5 minutes to 10. Any other questions before? So let's see. Twitch. This was definitely run. Another guy said this was not enough info to troubleshoot. Yeah. Seems like the regular login would be better than this kind of thing for context. Yeah. Sure, no problem. No problem at all. Thank you for the input. Enough stuff. Thank you for showing us the car. No problem at all. No problem. No problem. This was a fun project. Again, we did it in 2 streams. So we're all in about 5 hours or 4 hours into the project. So nothing too crazy. It really went smooth, and it was fun. So what is tomorrow? Tomorrow is Saturday. So tomorrow at 4 p.m. PST. All right. So tomorrow 4 p.m. PST, and tomorrow we're gonna do Node.js, and lots of it. So we're gonna do Node, and we're gonna do React and Redux and more. So come check it out tomorrow at 4 p.m. and I will see you tomorrow. Thank you everybody for being here. You're awesome.